In this video, we'll be going over the main exponent rules in algebra, plus a quick intro to one from calculus. This chart puts all the rules in one place, so feel free to screenshot it and use it as a reference. The product rule means if you're multiplying numbers with the same base, whether it's a number or a variable, just add the exponents. For example, if you had x squared times x cubed, that will equal x to the fifth. If you had y squared times y cubed, that will be y to the fifth. So you're multiplying the same variable or same exponent or same base. You simply add the exponents. Now for the power rule, when you raise a power to another power, you multiply the exponents. So in this, a is the base. It can be any number or variable, and m and n are the exponents. Since you are repeating a power multiple times, you just multiply the exponents. So for example, if you have y to the third power, and that's raised to the fourth power, just going to multiply the exponents here, where you have y equals 12. You're taking y raised to the third power and applying it 4 times, so you just multiply 3 times 4. And this here at the top is various ways you can look at this if you're more of a visual learner, just getting this, where you have the m and the n together, the little dot or the multiplication symbol, all that means the same. So just so that we're clear with the power rule, this is the power rule for algebra. It is also called the power of a power rule. And this is different than when you get into the derivative power rule for calculus. So if you're reviewing this, or if you're kind of learning both concepts somehow at the same time, just remember that this is a different rule than when you get into the derivative power rule. And this power rule is also called the exponent rule as well, so you may see that. And again, this is related to the power of the power rule for algebra. Now for the quotient rule, when you're dividing two powers by the same base, you subtract the exponents. So in this case, a again is the base, any number or variable, and m and n are the exponents. You're basically canceling out repeated multiplication from the top and bottom, so you subtract. For example, if you have x raised to the 7th power divided by x raised to the 3rd power, you'll have x to the 4th power. You're dividing x raised to the 7th power by x raised to the 3rd power, which means 3 of those x's cancel out, and you're left with x to the 4th. So another way you can look at this is if you have, say, 7 x's in the top, and you divide that by 3 x's, well, you can cancel out 3 and 3, and that leaves you with 4. Now for the zero exponent rule, anything except 0 raised to the power of 0 equals 1. So in here we can see that a can be any number or variable as long as it's not 0. Why? Because you're not multiplying anything, so you're left with 1. For example, if you have 5 raised to the 0 power, that equals 1. If you have a variable like x raised to the 0 power, that is also 1. No matter what the base is, the result is always 1. Now for the negative exponent rule. A negative exponent means you're flipping the base to the denominator. So in this expression, a can be any number or variable, where n is a number. And it's not negative like a negative number. It just means the base moves to the denominator. So for example, if you have 2 raised to the minus 3, you can
put this whole expression in the denominator, and it will make this exponent positive. So instead of a -3, you have a +3, and you can simplify that. So really this negative exponent rule can be used as a tool to help you simplify and solve problems. It's kind of a tool just to help you get to where you want to go.
So let's look at the fractional exponent rule. So when we're starting out with this, a can be any number or variable, n is a positive number. This means you're taking the nth root of a. So for example, if you take 4, raise it to the 1/2 power, that is the same thing as taking the square root of 4. So whatever's in the denominator of the exponent is what's going to determine what root that you're going to be using. So another example, if you have 8 raised to the 1/3 power, that is going to be the same as taking the cube root of 8, which is 2. And just so it's real clear, say if you have 16 raised to the 1/4 power, we can take the 4th root of 16, which is 2. So whatever the number is in the denominator of the exponent is whatever root that you're going to take that number by. And of course, the square root of 4 is 2 as well. All right, so we just covered the basic exponent rules in algebra, including some special cases, and briefly mentioned the calculus power rule. And we'll dive into that deeper in the next video.